Welcome to our sessions. I I decided to put some R videos here to help you working with R. I noticed that some of you have some difficulties when you go back home and want to work on R, and that's quite natural. Whenever you deal with any software, you have to follow these steps very carefully, and after that, if you just miss one step, you cannot run the codes the way that they need to be. So I decided to design these tutorials here, and I start from the beginning. So for those of you who want to have a review of the things that have been covered in the class, that might be a very good idea to start looking over what is covering now. So let's get started and see what we have. So one of the things I want to emphasize here is that R is not a very low-level programming language, although you can do almost everything with it. What I need from you in this course is not low-level, so you need to use just high-level functions and just know how to deal with those functions. So the first couple of sessions would be on a couple of things that are necessary to understand the whole thing here. But after that, I'm just going to show you how to use the functions. And that is the one that you need for your projects and your homework. So let's get started with the easiest concepts here. The first thing I want to teach you is how to get a working directory from your R. See where R is looking after for data now. The simple command for that is get wd, that's get working directory. So if you run that, oh, by the way, whenever you want to run anything in R, you should just go, just take that command and press Command and Enter. So here, for instance, it shows that my working directory now is user Hamed data mining course at the bottom of the screen. Let's say you want to change that working directory. How can you do that? The easy way to do that is to go on this window. And here you can see three dots here, right? So if you want to change the working directory to some other place, you just need to click on these three dots. Then go and pick the directory you want. So let's say I saved everything that we have here in a folder called data mining course. So I just want to fix it to here, so I just press open. If you want to save it as the working directory, just click on More. And when you click on it, just set it as the working directory. Okay? So that's how you set the working directory. That means anytime you need to load any data from it, that's the place you should look after. So that's how you set your working directory. Now let's go and introduce vectors and scalars and see how you can work with those. So the first thing I want to mention is, if you want to write some comments for yourself, and you want to let R knows that they're not affecting anything, just use this hashtag or number sign and just write whatever you want. So I said that this is how you need to write your comments. I think it has just one. Okay, comments. Okay, perfect. So that's how you write the comments. So the first thing I want to cover is how to define vectors and matrices. Matrices. Okay. The easy way to define vectors is just write a simple case that is starting with C. So if you want to have a vector of size 3, that means it had 3 elements in it. You just write x is equal to c and those 3 elements. So here in our course we have c of, I think we had c of 275. I just want to be very much consistent with the notes you have. So c of 275 has 3 elements. So if you just write x now, it gives you 2, 7, and 5. Let's say you want to introduce another vector, and you just want to give it some order. Let's say you want to have a size of 3 vector, starts from 4 and goes 5 by 5. The way you do it is just using sequence. So anything you write inside it will give you the commands you want. And one thing to note is that if you're not familiar with the command here, you just want to use it, just use question mark before that function, and it gives you everything that you need. For instance, if you're not sure what this function sequence doing, just write question mark sequence. It gives you everything that you want. For instance, here it's just okay, from some place to another place by some increments. So that's the only thing we know. So okay, so we just do and replicate what is written there. It's okay, you should have from and to and by. So let's do that. So we start from 4. We go up to a value, let's say 10, and we just increase it by 1. So let's see how it does it. So y in this case would be anything from 5 to 10, because that's how it's defined. Another way to define a SQL is to use some other components with it. For example, you can say, okay, from 4 generate a vector of length 3, and just add the elements by 5. That means start from 4, generate a vector that only has a size 3, that has 3 elements, but each element is 5 units more than the previous one. So we have 4, 9, and 12. So let's see what it does. So let me run it. So y in this case would be 4, 9, and 14. 9 is 5 units more than 4, and 14 is 5 units more than 9. Okay? So if you want to add 2 vectors, it's very easy. It's just like x plus y. And x plus y, here you see the outcome. X plus y is 6, 16, and 19. Why? Because x was 2, 7, 5. Y is 4, 9, 14. The summation would be the element summation. So there would be 6, 16, and 19. That's how you do it. The next thing I want to share is how you divide 2 vectors, how you multiply. It's easy. It's just like any other programming language. So if you want to divide two outcomes, just divide it this way. So that would be the element division. So here would be 2 divided by 4, which is 0.5, 7 divided by 16, which is 0.77, and so on and so forth. And that's the same thing for multiplication and power. So if you want to have an element to element power, that would be a very large number. I'm not sure if R can handle it. Yes, it did. It does it element by element. For instance, 2 to the power of 4 is 16, 7 to the power of 9 is that large number, and 5 to the power of 14 is that very large number. So we're done with the vectors. Sometimes you want to manipulate things. If you want to manipulate things and have access to certain numbers here, then you have to use this format. So for instance, I want to have access to the second element of this vector, which is vector x, which is 7. I want to have access to that. You just put it in. You just use this format. If you want to have access to more of the elements, let's say I want to have access to element 2 to 3 of this x would be 7 and 5. You just use 2, 2, 3. That's how you do it. So that gives you 7 and 5. That's very easy to work with. One of the things that is very easy to work with is when you want to drop something from a vector or a data set. The way you can drop it is perhaps the most efficient one. Let's say you want to just drop the second element of x. Again, I use the same format we had, but instead of 2, I just write -2. That means just drop 2 from this element. So x will become 2 and 5 now. So the elements that are left will be 2 and 5. Let's say you want to drop more than 2 elements from here. You can do that easily too. You just say x, drop the first 2 elements. Here, remember when you wanted to ask it to give you more than one variable, you have a vector, you should put it in C, and that's exactly how you do it here. So x minus C of 1 to 2 drops anything that is x. So what is left is just 5, because 1 to 2 was 2 and 7, as you can see here. So the only thing that is left is 5. The next thing is how you define matrices. We are not going to use matrices directly in the course, but our data sets, if you think about it, are just matrices. So let's see how we deal with matrices. The way to deal with matrices, again, defining a vector and just put it in the matrix. So the way you introduce matrix is using matrix. That's how you introduce matrix. And one thing you put there is, so let's say I want to build a matrix from 1 to 12, and that will be a 3 by 4 matrix. So in the beginning, I just say, okay, that is from 1 to 12. My number of rows is 3, and number of columns is 4. So that way, I created a Z matrix that has 3 rows and 4 columns, and the elements of that is from 1 to 12. So if I just recall Z, the outcome would be 1 to 12 in a 1 by 4 matrix. So one thing that is sometimes being asked is that, okay, how can I have access to some elements of this matrix? Let's say you want to have access to 5, which is the second row and second column of this this matrix. So that's very easy. Just like vectors, you just write the address of where you're looking after here. But here your address has 2 elements, row and column. So if you run it, it just gives you the element you're looking after. Sometimes you want to just drop or keep some of the elements here. Again, you do the same thing. You just drop it the same way you used to drop it. Let's say I'm interested to drop the very first element of the matrix. That's how the very first row of the matrix. I say, okay, I'm interested in Z minus 1. That means from my first rows I don't need anything, and comma nothing. That means from the second row I need everything. So if you run it, that element drops everything that is in the first row and keeps everything else. Remember this, it's vital to keep this comma here. Or let's say you're interested to just drop the second column from this matrix. That's also very easy. You don't need to mess with anything. In rows, that's why I just put comma here. That means nothing has happened to the rows. And for columns, I just want to drop the second column. That's also relatively easy. As you can see, this was our original Z. This is where we just drop the second column, and you can play with that more. Let's say you want to drop the second column up to the third column, then you have to put it to the inside a vector. So if you run it, it just drop the second and third column of the matrix. So you can play with that. That was something you will use, or you have already used for homework number 1. One of the very cool things about matrices is that you can get the dimension of them very easily. So you just put dim gives the dimension of the matrix. Remember, your data sets are usually in the form of matrix. If they're not, the data frame is usually matrix. So if you want to get the dimensions of it, you just use dim of Z. It gives you 3m4. That means it has 3 rows and 4 columns. Another command that you can use is length. The length gives you the whole size of the matrix. They said the length is 12. That's 3 times 4, so it gives you the total number of elements that are there. Sometimes you are interested to get rid of something that you've defined before. Specifically, you want to repeat something over and over again, and you just noticed you made some mistake earlier. You just want to get rid of everything you did before, and you want to get back to what you want to have. The command for that is remove. But in order to remove something, you should first know what you have. So ls gives you the list of the things you have here. Forget about these three. These are the elements I introduced in some of the other functions I did for a project. So I have x, y, and z. So let's say you want to remove that from your memory. The command for that is rm. So let's say I want to get rid of x. Say rmx. So if I ask for x now, it doesn't know that because it's not defined anymore. It's already removed from there. Okay. So now let's work on generating random numbers. How can we generate random numbers? That's another question we should be able to do. The way you can do that is just using, so you want to generate random numbers. There's so many different random generator methods that you can use. The most famous one is a uniform distribution. That means for a specific interval, you want to have each element of that same chance to be chosen. Another very famous random number generator function is normal random distribution, which gives the random numbers from the normal distribution. So let's work with, let me see what I have here. Okay, the second thing, let's work with uniform distribution. So in order to generate a uniform distribution, you just need to say random, R stands for random here, uniform, and the size that you want to generate. So X here is a uniform, that's a vector of size 50 of uniform numbers from 0 to 1. If you want to extend that, if we want to generate random numbers from, let's say, 1 to 10, then you can just multiply those numbers by 10. That gives you numbers from 1 to 10. Okay. So that's generating numbers from uniform distribution. So now, how can we generate numbers from the normal distribution? That's also very easy. Say, okay, Z is random again. R stands for random. Normal. Let's say we want to generate size. R norm. Sorry, it's not normal. It's norm. R norm of 50 generates a vector of size 50 from standardized normal distribution, which has mean 0 and standard deviation 1. As always, if you're not sure what the function is doing, just put question mark and just type the function. It gives you everything that you need. For example, for normal distribution, okay, if you want to mess with me, you want to change the mean from 0 to something and standard deviation to something else, it's okay. You can just do it. Just write mean equal to 5 and SD is equal to 10. So let's generate some other normal distribution. Say, okay, R norm. Let's say size again 50. Here I just want to change my mean to 5 and standard deviation to 10. So if you look at T, now the numbers that are generated has mean 5 and a standard deviation 10. Sometimes you're interested to plot two variables simultaneously. You want to see how you use one variable and what's the correlation of these two variables. The best way to look at it is to visualize it. Okay, in R, it's pretty easy to visualize things. You use plot, say X and Y, x and z. I just want to plot x and z. They should have same dimension. Remember, z had um, 50 elements and x had 50 elements, so it's compared them one by one. So let's plot them simultaneously. What you see at the right are the points that have different x values. As if, for instance, this dot here has value 0.2 for x, value minus 0.5 for, or minus 0.4 for z, and so on and so forth. You can do a lot with plots. You can just define what the x label is, what your y label is, how you can change dots to stars, to triangles, to anything you want. So for more information, you can just write what is plot, and everything that you need is given to you here. So my suggestion for you is, anytime you have any problem, just put question mark before that function. It gives you the elements of that. If you do that and you don't get anything from it, that only means you didn't use libraries correctly. So here, everything that I'm using are preset in R, so I'm not imposing anything on it. But you may come across some cases that you're using some advanced functions that are in ISLR library. So if you put the question mark before, let's say, an ISLR library command like regression lines there, and you don't see anything there, that means you didn't, you haven't uploaded that library yet. So some of the easy things you can do with plot is just defining x label and y label. So let me do it for you. So x and z, if you want to use x label, you say, okay, x label is equal to, let's call it this is x. You can write whatever you want here. My y label, this is y. This is y. And you can just add title, change the colors. You can do a lot of things. I think this is our title. So if you just run it, why? Okay, let me rerun it again. Okay, something is wrong. X and Z, plotting X label. Oh, X label. Okay, sorry. It should be X lab. Okay. Okay, this is X, this is Y, and the title is something. Okay, so that's how you fix that. You can also define histograms. Let's see the histogram of Z. It's very easy. It should look normal. Yeah, it's relatively normal. Around 0 is standard deviation 1. Our histogram of T should be a normally distributed case. Remember, this is a simulated number. That's why it doesn't look completely normal. If you want to see that beautiful shape, you should generate more random numbers. Let's call it NN. NN is our norm of, let's say, 100,000. Now if I draw its histogram, it looks perfectly normal. Yeah, it's perfectly normal. Okay. You can do a lot of things with that. One of the handy things is using mean. So let's find mean of T. Is 6.10. You can find the standard deviation of T. Here is 8.97. You can get variance of T. And so you can do a lot of things with that. The last part of this lecture is about sorry, I forgot what I was saying. The last part of this lecture is how to read data, reading data. So in the beginning of the course, I said whenever you want to use some data, it should be in your directory, or it should be in the library you have. So now I want to read my auto data. That's the CSV data that is in your textbook website. So please download it, put it in any directory you're comfortable with. But make sure you follow the instructions I said in the very beginning of the class. If you want, you can just go back to the very first seconds of this lecture and see how I set the directory. So make sure you set the directory in the same place you saved your data, your auto data from your website. So one thing you can do is just read it as a CSV file. So you just say auto data. You want to read it as a CSV file, you just write read CSV. That's how you read a CSV data. Then at first you should define its name. So the name of our data is auto CSV. If you rename it, you should rename it in your files as well. And just put header as true. That tells R that you have some headers, and that's the name of your variables. Usually the first row of your data are the names of your variables, so header is true. And then in this special data set, the missing values are shown by question mark. So now I read my data, I put them with auto data, told them that the header of that, which are the name of the variables, is there, and also any missing value is shown by the question mark. You might be in, and now the second thing you should do is to get rid of those variables, because the missing variables are not that helpful. So here you say, from the auto data that you introduced, please omit the things that are NA, not available. So NA omit. So here, by this first command you introduce, that those values are question mark, and here use NA omit to get rid of them in your data. So now your auto data doesn't have any missing value. It has all the values you want to see. So you can write just summary of auto data. It gives you okay auto data. You can ask for the summary of the. Then if you run it, it gives you all the variables you have at mean, maximum, first quartile, third quartile, median, and mean. So here are the values that I have. These are mpg, mile per gallon, cylinders, displacement, horsepower, and so on and so forth. So if you want to have access to those individual variables, there are two ways to deal with that. Let's say I'm interested to plot mpg versus horsepower here in this data. The first thing you can just do is just write auto data and use $mpg. That is saying that my variable is mpg of my auto data. Okay, and let's say I want to plot it against horsepower or weight. So auto mpg, which is the mpg, is the x variable. So whatever you put here at the beginning was the x variable, and this is y. As you can see, it's an inverse relationship between the two, and it's somehow not linear. So that's the first way you can get access to that variable. The second way is to make your life easier, and that is using attach. So if you write attach auto data, then you don't need to use $sign anymore. These variables will be local to it from now on. So then you can easily write plot mpg versus weight, and you see it knows that. Here, if you look at the values of name, for instance, that's a factor variable. So you have different names. These are the different brands of the. There are different brands of cars. There's also another variable which is called origin. Origin changes from 1 to 3. If you look at the original data, origin 1 to 3 talks about U.S. cars. European cars and Japanese cars. So one is, I forgot what one stands for. I think that one was for US cars, two was European, and third one was Japanese. Do not believe me, just check it out, and the definition of data, there's a dictionary for that. So if you want to change something that is defined as quantitative variable, here 1, 2, and 3 are just quantitative variable, and you want to make sure these are categorical when you use it in regression lines and so on and so forth. The handy way to deal with that is to just use a function called, sorry, I had to write it in above, a function called as factor. So before I run it, let me plot MPG versus origin. I haven't changed it to as factor because I didn't run the code. You see this very ugly case, right? So it was better to fix origin as MPG. As you can see, you cannot read it that well. We need box plots to understand it way better. So one thing you can do is just use the factor variables, and by that you just changed origin to a qualitative variable, to a categorical variable. Instead of quantitative, which was just the basic variable, you changed it to a quantitative variable. So now, when you do that, you have an easy life. Why? Because if you just plot it against MPG, it gives you the box plots of that. Apparently, Japanese cars have better MPG versus European cars, and then our American cars. The last thing I want to share is that you can use a command called pairs. And what it does is give you the 2 by 2 graph of your whole variable. So if I just do it on auto data, it takes a while. Yeah, it shows you the 2 by 2 relationship of the two variables. For instance, it shows the weight and horsepower have very linear relationship, or displacement and horsepower is also very linear relationship, and so on and so forth. So you can see 2 by 2 cases here. Or sometimes you're interested to just pair part of these variables. Let's say you're interested to just pair MPG on something. Then you have to use MPG and then tilde, and then the variables you're interested. Let's say I'm interested to find the plot of MPG versus cylinders, also acceleration, and also weight. See what I did. MPG was the first one. I put it at the beginning, and then tilde. That means on these three: cylinders, acceleration, and weight. So if you run it, you have MPG at the beginning, and then you have everything. Because now it's way more readable. So that was our very first video lectures on R. I hope you enjoyed it, and I hope I can share it somewhere that you can have access to that. Because I can look at the video file now. It's 1.26 gigabyte. I have to see how I can share it. Thank you very much. We'll have our next sessions later.